Hello everyone, today we are solving the problem find an integer starter 73 division 1. So in this problem we have given two integers x and y, and we have to find an integer n which will be awesome when it is lying in this range and satisfying two conditions. The condition is when I add y in n, then it should be divisible by x, and when I add x in y, then it should be divisible by y. So we don't have to minimize the answer. We can output any awesome integer n. So let's see some cases. So first case is either the x is divisible by y or y is divisible by x. So to satisfy this condition, the n plus x should be a multiple of y, because if it is a multiple of y, then it should be divisible by y. So the first multiple of y is y itself. So the n plus x can equal to the y. If n plus x is equal to the y, then it is also divisible by y. So the value of the n which will come out will be y minus x, which is the difference between the y and x. So let's see. Let put the value of the n in the two conditions. So in the first condition is when I add x, then it should be divisible by y. So the n is difference between the y and x, and when I add x in n, then it is coming out y, and yes, it is divisible by y. Okay, let's see the second condition. The first one is satisfied. So the second condition is when I add y in n. N is basically the difference between the y and x. So when I add y, so the number is coming out to y plus x. So it should be divisible by x. Okay, so you can see one thing, that this x is divisible by x, and yes, and one more thing is 2y is also divisible by x, because initially you are checking one condition, which is whether y mod x is 0 or not. If it is so, then this condition will also satisfied. So in this case, the value of n will be y minus x. But there is one edge case when both numbers are equal. The value of n will be difference, which will be 0, and it is valid, but it is not the possible value of the n, because the n value is lying in this range. It should be greater than or equal to the 1. So in this case, you are getting the value of n as 0. So you can just make the value of the n as x. Yeah, this is the edge case. You can just make one if condition and just make change the value of the n. So let's see some other case. So you have given two integers x and y. Neither x is divisible by y nor y is divisible by x. So to find the value of the n, let's satisfy the each equation separately. So to satisfy the first equation, what I can do is to eliminate this plus x. I can convert my n to n minus x. So here I just convert my n to n minus x. So this x will cancel out each other, and only thing which will remain is n. So what I need is the n should be divisible by y now to set it in the first equation. So here is n should be divisible by y, and to satisfy the second equation, I convert the n to n minus y. This y will cancel out each other. Now to satisfy the second condition, now n should be divisible by x also. Okay, so the possible value for each equation of n is coming out n minus x and n minus y. So let's merge it. So after the merging the value of the n in both the equations, it is n minus x minus y, where n should be divisible by both x and y. If it is divisible by both x and y, then my both equation will be satisfied. So the possible value of the n can be x into y, which is a number which is divisible by both x and y. So my answer will be equal to the x into y minus x minus y. This is the value of the n which I can find and satisfying the two condition. So let's use this answer in one test case. So the x and y is basically the 3 and 7. So and my n value will be the x into y minus x minus y base, which is 3 into 7, which is 21, minus 3 minus 7. So let's put the value of the n in the two equation, and let's check whether it is correct or not. So when I add 3 in my n is basically this number. So when I add x, which is 3 in this in n, then it is then 3 will cancel out each other. Only term will remain, which only term which will remain is 21 minus 7, and 7 is also divisible by 7. 7 is basically y, and 21 is also divisible by 7. So first condition is satisfying. Let's see the second condition. So when I add 7, which is y in n, then it should be divisible by x. So n plus y, 7 is cancel out each other. The term will remain as 21 minus 3, and this 3 is also divisible by 3, and 21 is also divisible by 3. So both our condition are satisfying. So for the case when neither x is divisible by y nor y is divisible by x, so the answer of n can be x into y minus x minus y. So let's see some code now. Okay, let's see the code of this problem. So initially I have taken the input of x and y, and the first condition is when x is divisible by y, or y is divisible by x. If it is so, then I just take the absolute difference of x and y in my answer. And if x and y are equal, then answer will be 0, which is not valid, because the value of the n is starting from n. The value of the n is starting from 1. So I just make it equal to the x and just print it. And in the else part, I just count the value. I just count the x into y minus x minus y. So this is the simple code of this problem. If you find this video helpful, then you can like and subscribe to this channel. Thank you.